Okay, this is section 4.4. I'm going to split this into two parts because Hawks splits it into two parts. They do 4.4a and 4.4b. So this is the stuff for 4.4a. When it comes to graphing equations of lines, we have three main forms that we use. We have the standard form of ax plus by equals c, slope-intercept form, the mx plus b, and then we have point-slope form. This is probably my least favorite of them. It does have some uses, but I feel like that in this section, Hawks trying to kind of make you use this is a little forced and unnecessary, but that's just my personal opinion here. So here's the point-slope form. Now really, for the point-slope form, it's very descriptive. You need a point and you need a slope, right? You need a point, x1, y1, and you need a slope. You plug that in, you're good to go. Now really, the point-slope form is really just a variation of the slope formula. Remember the slope formula of y2 minus y1 over x2 minus x1? Well, look, if you take that formula and you divide both sides by those parentheses, you get what looks like the slope formula. So let's look at an example. So we have this line, y minus 1 equals 2 times the quantity x minus 3. We're going to graph it, we're going to label the slope, and at least 2 points, because that's what Hawks asks us to do also. Now, one way you can do this is by comparing this to the point-slope form. So we have this point-slope form of y minus y1 equals m times x minus x1. By matching these up, you can get that the slope is 2, the x value of your point is 3, and the y value of your point is 1. So we get a slope of 2 and a point of 3, 1. So we know how to graph that, right? If we have a point, we have a slope. We start at the point, and we use the slope to tell us how to travel from that point, right? 2 over 1, so we go up 2 over 1. Remember that? Remember that show from such hits as the last section that we covered? So that's the up 2. And that's the over 1. Now, I'm not a big fan of this because the point-slope form has these minuses in there. I feel like it's really confusing for students. I feel like they're going to make a mistake and say that the x value is negative 3 and the y value is negative 1, which is going to mess everything up. So, my suggestion is just don't use the point-slope form. Hawks is going to, but just don't worry about learning a new thing. Instead, if you do a little bit of work on the front end of just, distributing this 2 throughout there, and then adding that 1 over and getting it into y equals mx plus b form, then you can continue on the way we were doing it before, right? We got slope, we got a y-intercept. Grab my highlighter here. We got that same slope of 2 over 1. That's an up 2 right there. And that's to the right 1, which is right there. So it's the exact same line. Now, you may be looking at that going, that's not the same line. Well, it is. You just have to squint and use your imagination because my scale's off. But if this were to keep coming down, it would hit that intercept right there at negative 5. This right here is going through 2. So these are the same line. My scale's just a little wonky because, I drew it by hand. So if it's all the same to you, if you want to use the point-slope form, you can, but I'm really partial to the y equals mx plus b because that shows up so frequently that it's just totally worth it to use it, in my opinion. So that's the one I'm going to go with. I'm not going to try to get it into point-slope form, especially something like this. This is really awkward to get it in point-slope form. So I'm going to subtract that 2 over. Now, check it out. Y equals mx plus b. M is negative 5. Remember, if there's no denominator, you put it over 1, not negative 1. So, as always, we start at 0, negative 2. From there, we go down 5 and to the right 1. So let me grab my color coding here. We're going to go down 5, and then right here that's a positive 1, so we're going to go to the right 1. So these are just an extension of what we were doing in the last section. You just now have to do a little bit more work of getting it into the correct form. Okay. This is another one where I'm going to have to distribute. Remember, that's just a -1. So I am going to distribute that -1 throughout those parentheses, and I get negative x minus 8. That coefficient right there is an understood 1. So we get a slope of -1 over 1. We get a y-intercept of -8 down there. And you guys know the drill, right? -1 means you go down 1. Positive 1 means you go to the right 1. Boop. It's kind of hard to see that, but I feel like by now you guys are kind of, understanding. Now, this one, we're going to find the equation of the line in slope-intercept form. Here's my slope, here's a point. Okay? We're not going to graph these. So Hawks is going to use the point-slope equation because they're like, oh, you've got a point, you've got the slope. I just really don't like that equation. I feel like it's so complicated for students that it has been my experience that students just do better if we just stick with the slope-intercept. So that's the form we got to get into anyway, so let's just use it to begin with. Now, here's what we can do. With any point and a slope, you can plug in to this mx plus b. You can plug in the slope for m, obviously. You can plug in any point for x and y and then solve that for b. Then you can use the m and the b together. So y equals m, that was given, x plus b that I just found. So you can do this with any point and slope and not have to use the point slope formula. That point slope formula gets really messy because of the subtractions in there. Now this is not necessary, so we don't write it. If you do write it, Hawks is going to tell you to simplify your answers. Alright, we got another slope, we got a point. You guys know I'm partial to the mx plus b. So this is my x, this is my y. So that's my m. I plug in y 10, x -7. Multiplying these two together, I get 21 over 5. Then to solve for b, I have to subtract 21/5. Use your calculator to help you with that. That 10 minus 21/5. If you don't want to do that in your head, just use a calculator to help you. Write your little love note here. Use calc. Okay, so there's my b value. Now, the answer, y equals mx plus b. M was given, you just found b. Alright, how about m is undefined, and it goes through this point. This is a special case. Undefined slope means that is a vertical line, so it's x equals a constant. Now, which constant? Well, x, y. So we're going to use the x value, right? Because it's an x value. It's an x equals line. Similarly, if it's a zero slope, we know that's a special case. So let me just keep labeling these so that you don't think I'm skipping out on work here. This is a special case of a horizontal line. So that has the equation of y equals a constant. Now, which number do we use? Well, x, y. Use the y number. So it's y equals 1/3. They really are just that easy. But the trick is you have to recognize those special cases, that undefined and that zero. Now, in this case, if you didn't recognize this as a special case, check it out. You could have gone through the whole y equals mx plus b business and plugged in a slope of 0, you know, and then the point x, y, you would have gotten b equals 1/3. So y equals m, which was 0, x plus 1/3. That 0 goes away, and you get the exact same answer. Now that doesn't work up here. You can't plug in undefined. Don't put 0 in there. It's not the same thing. So that does work down here, but not for the undefined. Okay, so last one. We're going to find the equation in y equals mx plus b form of the line through these 2 points. Now this one is getting a little more complicated because now I don't have a slope given. So now I have to find the slope. Okay? Then I'm in the same position I was with the last one, that I can use the slope and then either point to find b and then write the equation. So I tried to write this out in steps to kind of break it down for you so that you could see what I'm doing and when. All right, so first thing, find the slope. You guys know how to find the slope, right? You just label these 2 points. I labeled them x1, y1 and x2, y2. So substituting these into that slope formula, I got a slope of 1/2. I just highlighted that to come back to it for later. Now we're right where we left off. Now we've got a slope and we've got 2 points that we want to find the equation of a line. You can pick your favorite point here. Whichever point you want to use, you'll get the same answer. I know that sounds crazy, but I promise you it works. This slope and either of these points. Okay, don't use a mismatch of them. Don't use like 2, 6. Either use 3, 6 or negative 5, 2. You can use that slope and either point. I picked 3, 6 because I just didn't want to deal with the negative. All right, y equals mx plus b. I'm going to plug in for x, y, and m. And I get this equation. So 3 times 1/2 is 3/2. Subtracting 3/2 from both sides. You can use your calculator for that computation. And I get b equals 9/2. Now, the pink and the yellow together are going to give me my final answer. Remember to try to do these along with me, and remember to do the computations with me to make sure that you know how to do these. All right, so that concludes section 4.4, part A.